Okay, hey guys, I'm about to make a selectable dummy load for a laser driver. Your basic components that you'll need is a 1N4004 diode. If you can't find these, anything in the 1N400 range is fine. These ones here are 400 volts at 1 amp, so these are perfect for what we use them for. Obviously, they have to be under 1 amp for your test for your laser current. You can get bigger ones with a bit more current, but these are the ones I'm going to stick with. I've got 3 packets here. They were approximately $1.50 all up for the 3 of those packets, and you get 4 in each packet, so 12 for $1.50. They're pretty cheap. Next, this is gold-plated header pins. They're 9mm in diameter, and it's a 50 pack. Those were $4.50 for a 50 pack. And basically, those are going to be in line with the top of these diodes, so you can use these shunts in order to select how many diodes you want to use for your dummy load. And these shunts were also $4.50 for a pack of 10. And lastly, we have a 1 watt 1 ohm resistor. This is obviously higher wattage than what we usually use, but this will give me more accurate results in the higher current range. Alternatively, you can use the smaller half watt diodes, resistors. As you can see, they're a lot smaller, but yeah, they're restricted to lower current. Another type you could use for your diodes is the 1N4007s, which are up to 1000 volts, 1 amp. These will give you a bit more leeway than these closer to the 1 amp, 1 amp current. So basically, what you need is a Protoboard. Optionally, you can use a third-hand Protoboard holder, I guess that's what it's called. The Protoboard I use has, for each hole, it basically has its own copper pad, which makes joining very easy, and you don't actually have to work in rows like other Protoboards require you to do. Other tools that you might need is tweezers, some wire cutters or tin snips, solid core wire, some desoldering wick. This is optional, you don't need this. A wire stripper. These are the old dinosaur type that pull your wire. You can use a knife or something hot to also strip it. And depending on your application, you will need different types of solder. So this one you can see is 3.5mm in diameter. This is way too thick for what we use it for. But for different things like making a PCB battery contact, that's good. I also have a 1.5mm diameter solder, which is also good for larger scale stuff, but is better than obviously the 3.5. But here I have a 0.5mm solder, which is extremely thin, and this is great for using on laser diodes and drivers because, well, obviously there's less solder to go on and it's just less mucking around. All of these three are 60% tin, 40% lead, and they're all rosin core, so they're great for soldering on for what we need it for. And lastly, what I have here is a heat gun and a soldering iron. My soldering iron has a very fine tip, which is good for small applications. You can see the size of it compared to my finger. And it's selectable, so basically I can select anywhere from 100 degrees up to 480 degrees, which is great for what we use it for. The heat range that I usually use it at is about 300 to 350 degrees. This is equivalent to maybe a 30 to 35 watt normal soldering iron. So yeah, that's already at 350 degrees. This is like pretty high-tech stuff. You don't need this, but if you can afford it, it's worth it. They're about $100 on eBay. The one I have is Seiki 898D. It's got the SMD rework station and soldering iron, all adjustable. The rework station is also good for heat shrinking, so you don't need to use a lighter or whatever else you need. And basically that's all you need to make this. So I'll go step by step showing you how to attach each component and what it does. Alright, so the first thing we're going to do is put the header pins in. The actual hole that's on this PCB is actually a couple millimeters too thin, and it's quite hard to put the header pins in. So what I did was I have some of these. They're actually used for cars, and they're very small drill bits. I think they're used for drilling out carburetor holes and trying to remove rubbish from holes and stuff. And basically they come in these tiny sizes. So 0.9 is actually the size of the header pins. See, 0.9 millimeter header pins. So what I did was I grabbed my 0.9 mil and I just slowly worked it out until I drilled through the PCB, just like that. And you just have to be careful that you don't damage the copper. As you can see, that one's a tiny bit larger than the one next to it. So that one should fit the header pin fine. So now to put the header pin in, what you do is, well, also I've left a gap, one gap between each header pin. That'll allow the diode to be put here, and then a solder bead that'll go down to here, connect to the bottom of the next diode, and then that'll be connected here. So this row will be used only for a solder bead. You'll see that in a minute. But yeah, so you drill out the rest of the holes just like this. And then you should be able to fit the header pins in just fine. What I use is these little tin snips or wire cutters, because they are very small and hold the pin quite well. And I just dropped one. But you basically grab it just like this, and you want to line it up with the hole as best you can, and then it should slip in just like that. And the shunts that I was showing you before are these. This is actually what's going to jump the two pins together like that. And that works fine for that size. These shunts actually have on the packet it says pin size 2.54 millimeters, whereas these are 0.9 and they fit perfect. So yeah, don't be scared to buy this size shunt. And now just repeat the process with the rest of the headers. I'm going to only use 7 diodes, so I've got one more after this, and then it's time to start soldering them in. Okay, so as you can see, I've finished putting in each of the header pins. Now I'm going to turn it over. And we'll solder each pin into its copper trace, just like so. So right now my iron's on 350 degrees, it's ready to go, and I'm going to use my smallest solder available, the 0.5 mil thick solder. So basically what you want to do, get a nice hot iron and put a bit of solder on the tip, just like so. And then you hold it down onto the trace and it should heat the trace, and you add a blob of solder just like that. Now repeat it for the rest of them. Put a small bit of solder on the top, heat the trace, and add a bit of solder. And as you can see, very, very easy. Heat the trace, add a bit of solder. Continue that for the rest of them, and remember to clean off the tip of your iron when it's not in use. Alright, so now I've finished soldering each of the pins in, and now we need to bridge each of the top pins together so it would make one solid connection. Basically what I have is some of that solid core wire I was talking about just earlier. I think it's about 0.5 or maybe 0.2 mil thick, very, very thin wire. And that's basically going to go along the top of each of those pins, so it'll make contact along the pin. If you did have the copper traces that were actually attached in rows, you could just drag a bead along the top, a bead of solder along the top of each of those pins to make contact. But I don't have that, so this is what I'm going to do instead. Okay, so what I've done so far is just tack the first and last header pin to the wire, and now I'll show you how to solder the rest of them onto it. It's the same process. So basically you want a clean soldering tip. You may need to add a tiny bit of solder just to help the transfer, so that's what I'll do now. Okay, so basically what you're trying to do is transfer the heat through the wire into the solder. Sorry, just trying to get a good picture for you. Alright, so now what I do is touch the end of the wire here on this side, and it'll heat it up, which will cause it to heat the solder blob on the header pin, which it just did, and it should get stuck into that solder like so. I don't know how well that got picked up. I might rotate this. There you go, that's a bit of a better picture. So basically same process, put a tiny bit of solder on here, on the tip, and push it into the header pin solder. Just like that. And then repeat for the rest of them. Okay, so now you can see that each of the top pins are connected electrically, and each of the bottom pins are not. They're on a separate pin. Now basically all that means is when you put your shunt in to select your diode, when you put your shunt in to select your diode, it is making contact with one of these 7 pins and attaching itself to this rail here. And then this will go up until up to your resistor. Your resistor will go through to your positive point here. Okay, so the next thing you're going to do is want to put in a 1 ohm 1 watt resistor. That can change, but please try and keep it to 1 ohm, otherwise you need to do conversions when you try to use it as a dummy load. Alright, so I've put in the 1 ohm resistor now, and I've also put in 2 more header pins just here. This is going to let you read from either side of the resistor. If I turn this over, you can see that I've bridged the header pin with one side of the resistor and then bridged the other side with the other side of the resistor. So now we have to connect this last 2 pins together, so it'll always make a constant contact with throughout the diodes, and so those 2 will be bridged, and then this top one will be bridged to this pin here, which will go through the resistor through to here and out to your positive point where you connect it to the driver. So we'll do that now. Alright, so what I've done now is bridge these 2 pins here, that is at the start of the diode. So the first pin of the diode comes out here, the anode side. It bridges these 2 pins and goes up until up to this pin here, the header pin. I then took the bottom of the diode, moved it over to the second rail. Remember how there's a gap between each pin? That's for this bridge here. So that'll take the power from the base of it all the way up to the top where the next pin is. And then I would solder the next diode in where that is, and it'll bridge the end of this diode to the top of the next diode. And just repeat that all for the next 6 diodes. Alright, so as you can see, I've soldered in 2 diodes. Now I'm putting in the third. Now the way I did this was I grabbed some tweezers and basically grabbed just before where I want the bend and twisted it just to make a nice clean bend. You may need to lift it up over the header pins, and you can basically get a really nice bend out of it if you use tweezers, just like that. So see the nice 90-degree turn here. You then do another one here. You just do another one here. try as best as you can to make it as clean as possible. Okay, so you can see the 290, well, as close to 90 degrees as I could get it, bends. And now see this excess here that's come off this is actually the diode pin itself, the wires off the back of the diode. So they thread through, and then it gets bent up into place like that. So basically, once you've done that, you want to get your little tin snips again, or wire clippers. Grab it just before the header pin, just so there's not that much overlay, and then cut it so it basically sits just like that. And you want to leave enough room for the next diode pin to come through that top hole there, and then you basically just solder it in place. Try and keep the work level, that way the solder won't run down to the bottom like it has with these, but try and keep it level and solder it in. So the best way is to get take a bit off the actual reel. So here's the reel. If you just heat it up and take a bit off, it's easier to work with just a stick like this instead of the whole reel. And basically what we do is put a tiny bit of solder on the tip, hold it to the trace, and add a bit more solder, and basically just do that for the rest of the wire. Make sure it touches all the pads. Like so. You may need to drag it across a bit just to get all the solder into the wire and into the pads. And then you want to heat the header pin and stick the wire to the pin, and that's about it. Simple as that. Okay, now to finish off, you put in your positive and negative input, and I've just heat shrinked it just to keep things nice and neat. All 7 diodes are in. You can see the shunt is working. You can easily select which diode you want, like that. This is pin 1, so if you only want one diode connected, you put the shunt on the first one. 2, 3, 4, 5, 6, all the way up to 7. 7 you don't actually need to put the shunt in because they're connected, as I showed you before. Those 3 pins here, these 3 pins here are all connected, but I thought I may as well put the pins there. And you can just rest the shunt on there like that when testing. So now I'm going to do a little test. I have my voltmeter, my multimeter here, is resting on my Heaney tube. This is the dummyload, the multimeter here, and just off camera to the left I have my DC power supply. And what I'll do is I will place the shunt on number 1, connect up my power, obviously negative to negative, positive to positive. And as you can see, on the DC power supply. It's pulling about 892 milliamps. That's not exactly the best way of testing because it's a bit inaccurate. But so yeah, if you just have a look here at the voltmeter, since I'm expecting it to be around 800 milliamps, 800 to 900 milliamps, I've got my my meter in the 20 volt mode. I could also have it in the 2000 M mode, which will be up to 2000 milliamps. In this case, we're checking voltage across a resistor, which would mean 1 millivolt equals 1 milliamp. Use Ohm's law to work that out. So basically, if I'm testing between 0 and 200 milliamps, I would have it on the 200 M mode for more accurate decimal place. When you switch it to the 2000, you have the 3 decimal place. 20, you have only 2 decimal place. So I'm going to switch it to 2000, and we'll check the milliamps that's running through here. So basically, I'll put that down in view, and I will place the positive probe on the right hand side where that first pin is. And then I will place the negative probe on the left hand one. And I don't know if you can see that, but we're getting about 960 milliamps through the dummy load, just like that. So now if I pull it up to the next diode, I'm expecting about 300, maybe 290 through here. Place it again here and here, and we're getting about 310 through it. So, and it's quite stable. So if you use this resistor as I showed, 1 ohm 1 watt resistor, you get very accurate results, and quite stable as well. So yeah, that's good. So the last thing you need to do is cut it out. I used a fine tip coping saw, very fine tip, and it was quite easy to cut. Cut along the holes to help you go straight. There are lines on the board, but yeah, sometimes doesn't come out very straight. Obviously leave enough room for all your electronics, and that's it. You're done.